Okay, this is the Unit 8 review. The first problem asks, I don't have it written in front of you, I'm just going to have to read it off. You can follow along, hopefully. Number 1, specular reflection obeys the laws of reflection while diffuse reflection does not. That would be false. The reason why is because specular reflection is a smooth surface, so you're just going to have a reflection in a normal, organized way. Diffuse reflection is where you have this rough surface, this rough, complicated surface here. And what you have is when light comes in and reflects, sometimes light comes in and reflects, at different angles, basically. So, the road actually looks like this if you zoom in microscopically. So when your lights shine on the road, it looks pretty normal. But if the road is a flat surface like a mirror, it would look really funny. That light that comes off your headlights wouldn't bounce back, and you wouldn't even see, the road wouldn't even be illuminated. So the first one would be false. All right, next question, number 2, says a convex mirror forms a virtual diminished and upright image for all real objects regardless of the location of the object. Now, all these questions you can refer to your formula sheet. So if you just take a look at that, obviously you're in this last column right here where you have a convex mirror. The image is always reduced and virtual, and the image is always some size in between, or some distance away from the mirror in between the focal point and the mirror. So the answer to that one would be true. All right, so then the next question, a convex mirror of focal length 10 centimeters forms an upright and magnified image of a real object placed at a distance of 20 centimeters from the mirror. Once again, let's look at the formula sheet. So if you look at the formula sheet here for convex, our object's not going to be magnified because it's always reduced. It's always a reduced virtual image, so this has to be false. Next question is 4. A concave mirror of focal length 10 forms an upright and diminished image of a real object placed at a distance of 5 centimeters from the mirror. So I'm going to write those things down real quick, what they told me. Focal length 10. Distance of the object is 5 centimeters from the mirror. And that has to be false because if you look at concave mirrors, if we're going to have a reduced image, it's got to be inverted, not upright. And they say in the problem that we have an upright and diminished image. Therefore, that can't happen with a concave mirror here. That's not one of the options that we have for our concave mirrors depending on where we place the object, so therefore it has to be false. The next question is number 5. Number 5 says the angle at which a light ray reflects off a smooth surface depends on its wavelength. And that is false. We know that light reflects, we know that light reflects the same angle. So whatever angle this is, call that the incident angle. The reflected angle is going to be exactly identical. Next question is number 6. Number 6 says the law of reflection applies only to surfaces that are smooth on the scale of the wavelength visible light. That is once again false. If you have a microscopic image like the one I just drew here and light comes in, it turns out that light comes in at the exact same angle as it reflects. So whatever angle is here, that angle will also be there. So light follows that same property. Next question is number 7. Number 7 says a plane mirror produces a front-to-back reversal of objects. That is true. In fact, you can get some of that information from here. Actually, that information is not on this column, but you know from looking in a mirror that things flip. So your right arm looks like your left arm and so on. So that is true. If you look at letters from a t-shirt, for example, as you look in the mirror, they're hard to read because they're backwards. Okay, the next question then, number 8, says the focal point is the point through which parallel incident rays reflecting off the surface of a concave mirror converge, and that is true. So if you have a concave mirror, the focal point right here, if you have parallel rays coming in, then they'll always reflect to the focal point, which is exactly what they asked for number 8. That is true. Next question, number 9. Number 9 says the images produced by a convex mirror are smaller than the objects it reflects. So if you look at this, they are always reduced from a convex mirror, so that is true. Okay, now for some short answer questions. Number 10 says we have a 5 centimeter real object, so that's the height of the object, is 5 centimeters, and it's placed at a distance away of 30 centimeters. From a concave mirror, the focal length they give us is 10 centimeters. And they want us to find the location and size of the image. So we're looking for distance of the image and height of the image. So we're going to look at our formulas off our formula sheet. So we have a concave mirror. Now we need to figure out which one we're in, which row we're in here. So what you want to do is you want to look at the information that they gave you. They gave us the focal length was 10. That means we know what that is. We also know what r is. R is twice that, so r is 20. That's the radius of curvature. So the distance to the image is 30, which means we have to be in this one then, because the distance of the object is greater than the radius of curvature. 30 is greater than 20. So we know we're right here. We know the image then has to be between the radius of curvature and the focal point. We know it's going to be reduced and inverted in a real image. Now, the math relationships we can use. So here's the relationships right off the formula sheet. We're going to use the mirror equation here. So that's 1 over 10 equals 1 over the distance of the image is what we're trying to find, plus 1 over distance of the object was 30. And all you have to do is solve for distance of the image. So I'm going to make this 3 over 30, multiply top and bottom by 3. That way I can subtract 1 over 30 from both sides and get 2 over 30 equals 1 over distance of the image. Divide both sides, and what you find is that the distance of the image is 15. And so now we know that's 15. And we know from also looking at this that that image is, it's a real image. It's reduced and inverted. So once again, it is reduced. It went from 30 to 50. So that makes sense. And also we know that the distance of the image is in between the focal point, which is 10 centimeters away, and the radius of curvature, which is 20, so it makes sense. Everything checks out so far. We did it right. Now the height of the image, we're going to use this equation right here. So go ahead and plug in. The height of the image is what we're looking for. The height of the object is 5 centimeters. That's going to equal the distance of the image, which is 15, over distance of the object. Multiply both sides by, I'm sorry, this is 30. Multiply both sides by 5, and what you get is 1/2, so it'll be 5 halves, negative 5 halves. The height of the image is negative 5 halves. And that negative means that it's inverted, but we already know that, so that's not a big deal for us. So it's negative 2.5 centimeters, or 2.5 centimeters inverted. Next problem is question 11. Question 11 says a 3 centimeter pencil, so I'm going to write all this down really quickly, is placed 10 centimeters in front. Alright, so once we know the height of the object is 3 centimeters, the distance of the object is 10, we can answer the question, which is find the height, location, and type of image formed by the mirror. So let's go up here and look at a plane mirror. We know that it's going to be the same size. We know it's going to be virtual. So we can say that. We know that it's going to be 3 centimeters away. It's going to be, 10 centimeters away, 3 centimeters high. It's going to be a virtual image that's going to be flipped. There you go.